So welcome back. My name is Amir and this is part 5 of Chess with React. In this part we are going to move the pieces according to chess rules. Right now you can see that I can jump over the pieces and there is no any rules that is going to be working here. So let's go and fix that. The first thing is that I just want to have a entity called the arbiter, and this arbiter is responsible for the correct moves and a bunch of other rules like are we in check, can we do en passant, can we capture, and do the take back and other stuff. So this has a entry point called the arbiter.js, and for now let's add another file called the getMoves.js, and this getMoves.js will give back the moves for a piece that we want to move. So this was a mouthful. Let's leave them as is for now. Go and implement the logic and then we will add it to these two files. Okay, let's go to the components and then pieces and then piece.js. We're starting the drag here. So first I would like to grab the app state and the dispatch function from our and this app context I believe lives in the context folder if I'm not mistaken. Yes, like so. And I can grab the turn to see whose turn is it, and also the position, the list of the positions that we have from the app state. These are the values that I want for now. And from the position I can say that the I'm only interested in the current position, which is the position at position.length -1, the last item in the array of the positions. So now that I have my current position and everything, I can start writing. So here I can say that if turn is my turn, so it's the same as the piece that I grabbed to move. If this is true, then I can do the dragging. So okay, I would say that give me the candidate moves, meaning the moves that I can make with that piece in that position. Let's say this is just a function that we have here. This will move later on to the arbiter. So let's say get moves. Say that first you cannot move anywhere. Then you need to tell me who is the enemy and who are we. So we are the color white or black. The piece at index 0 will tell us either we are white or black. And the, let's say, enemy is if we are white, then enemy is black. Otherwise, enemy is white. Now that I know who is us and who is enemy, I can implement the logic. So I would say their direction is the direction that a rook can move is going in this way, going in this way, going up or going down. This way means my rank is the same, but I'm decreasing file one at a time. In this direction I'm increasing the file, rank is the same, and here I'm increasing the rank and here I'm decreasing the rank, and the file are the same. So in other words, I can move in this direction, in this direction, in this and in this direction. And for each of these directions, am I going to land on an empty spot? Am I going to land on an enemy piece, or am I going to land on my own piece, or am I going out of the box? So these are the four things that I can check. First, let's check if I can go out. So for each direction, I would say that for I from 1 until I is less than 8, because we can go only 7 spots, 1, 2, 3, 4, 5, 6, 7. So for I from 1 up to 8 or less than 8, I can say that x, which is the new position, the rank of the new position, is the rank that I am already in plus I multiplied by the IR at index 0. So I am going in this direction. And y is also file plus I dir 1. So if that tile is valid, so check the current position at index x, index y, and see if it's undefined or not. If it's undefined, then we should break. We shouldn't continue. We cannot move any further in that direction. But let me say that this is like this, because x might be out of bounds before we get to y, and we don't want to get any error here. So otherwise, if that is a valid, means it is in the board already, we can check that if it's an enemy or not. So is that spot on the current position starts with an enemy, then I can push to the moves this position and I can break, because I cannot move any further after that. And if that position is one of our own pieces, so that starts with us, then we should break, because we cannot capture our own piece. And if it's none of these, then it's an empty spot, meaning I can move to that one. So let's say that moves.push just x and y. I can remove this, and when the direction is done, I can just return the moves. Let's log it for now. So candidate moves like so, and you can see I cannot move anywhere, and the current position is not a function. This is starts with, and this is starts with. Refresh, and you can see I cannot move anywhere because all the spots are taken. So let's go to the helper and remove the pounds for now. Check again, and I should get 7. Yes, I'm getting 7. 1 7, 2 7, 3 7, 4 5 6 and 7. Awesome. Now if I move this, I would expect that it would go from 2 7 up to 6 7. Let me see that. Yes, 2 7 up to 6 7. Cool. Now if I move this one, I would expect 1 2 3 4 5, and then 7 here, 12. Yes, I'm getting 12 different locations. So this is working fine. Okay, so let's move these logic to its own place. I would just grab this and put it in the get moves, and now I say get the rook moves because this is just the rook moves, and I need to export it. This needs the position, and this should be position to make it easier to read. Then the thing that I want is the piece, and I need the rank, and I need the file here. And this is the arbiter that would call this. So in the arbiter, I would say that arbiter, which is an object, has a bunch of methods. One of the methods is get, let's call it regular moves, because for pound there are like regular moves and attacking moves, and so I need to separate them from each other. So get regular moves is a function that it will accept these values, and for now it just returns get rook moves, and it will pass it these values. Then later on we can check that if the piece is rook or not, and then we would call this. For now this is dumb and it's only called the rook moves. Export default and the arbiter. Cool. Now in the piece I can just call that one. So arbiter dot get regular moves, and I need to pass these values, and the position is now the current position that we are sending. So let's go back, and I expect the same result. So what I'm going to do with these valid moves is two things. One is that I can check that if the piece is being dropped on one of the valid squares, then that's a valid move that will be done on the undrop. The other thing is that as I start dragging, I can highlight. So if I go here, I can see that these valid moves are implemented like this. So if I am attacking an empty space, or in other words, if this is an empty spot, then it's a small circle, and if it's an enemy, then it's a round big circle. So I'm going to implement that. In order to do that, I need to find a way to send these values to the board so that when I start dragging, the board knows what are the valid moves and highlight the tiles accordingly. In order to do that, I would just say dispatch, and I have already defined it here. Another function, so it's like generate candidate moves, and I will give it the candidate moves. And this will just write the candidate moves in the reducer so that the board can use them. So let's go to my actions in the reducer. I would have something similar. This is candidate moves, and I'm passing it here. This should be generate candidate moves, like so. And I need to define it in the action types. So here, this is like this, like so, and the comma. So now that I am sending the dispatch, I need to grab the dispatch. So I would say that like this, but case if it's action types dot generate candidate moves, then let's say that return whatever the state was, and then candidate moves is the action dot payload dot candidate moves, like so. And I need to define it in the beginning, so let's go to the app init game, and I would say that the candidate moves is an empty array in the beginning. So I'm getting the candidate moves now. Let's save. Let's see what's wrong here. Okay. This is the import issue. Now it should be okay. So let's go here, and I would open my components here. Go to the app state, and current moves candidate moves is empty. As I drag, you can see that there is an array here of the points. Now I can consume this in the board.js. First I need to grab it, so I would say give me the app state. I don't want to dispatch anything here, so it's just the app state. I'm grabbing this, and I would say that the position is app state dot position at app state dot position dot length -1. Okay, so I'm getting the current position, and here in the class names I would say that if like app state dot candidate moves, if this candidate moves is one of the tiles that I'm already in, so I need to highlight it. So if this candidate moves exist, and I can find a, let's call it m, and m, which m at index 0, which is the x or rank, equals to I, and m at index 1 equals to j, then that is the spot that I can move to. But I need to do another check. So if position at I and j, if this position exists, then it's an enemy, because we already checked in the piece and removed the, because we have already checked here and removed the pieces that remove the tiles that we can go with our own piece. So if there is something here, then it's an enemy. I would say that that this is an attacking. So we are attacking this. Otherwise it's an empty spot, and we can just highlight it. So C plus equals just highlight. Okay. Now let's go back here, and so if I move here and I go to the elements, grab this. So this is the pieces. I need the tiles. I'm attacking here, but I should be attacking like here, so I'm 2 spots off. Let's go here. This shouldn't be 9, this should be 7. So if I refresh now, if I move the rook anywhere, now I'm attacking this specific spot, and this I'm highlighting. These are the highlight, which means like these ones, and this one is the attacking. Okay, now I can write the CSS for that. Let's say that the highlight, let's do it here instead. So I would say that the highlight and then the after, because I don't want to change that tile. So the after should be first the content should be like so. The display should be black. The position should be absolute. Let's say that the width is I don't know, let's say half of the tile size. Same should be for the height as well. So height is also this value. And let's give it a background color of red. Yes. So I have it here. The border radius should be like 50%. And let's say that the left is 25% and the top is also 25%. So yeah, these are the highlight. The background should be something else that we will define. Let's grab this rule, go here and say that highlight that after is this. Let me go to my constant. I have a highlight here, so let's grab the highlight and say the background is that highlight color. And if I go back here, refresh, yep, I'm getting the highlights. Cool. Now this one is remaining. This should be just like this with a little bit of change. Let's call it attacking first. Let's go here. This is attacking. So I don't want the back. No, I want the background. I don't want the for the attacking. I am not getting the attacking here. Yeah, here it is. So I don't want the background, but instead I want a border, let's say 10 pixels and then solid and then red. Okay, this is a little bit off. Let's give left a 0 and the top 0 as well. The width should be the same as the tile size, so this, but minus, let's say 20 pixels, like so. And this should be the same for the height as well. It's a little bit too big. Let's make this like 8, 6. No, 6 is good. I'm happy with 6. And this should be then 12. The same for this one. Awesome, cool. I like this one. So let's grab this part put it here. Don't want the background, and the border is the same, so this should go here. And yes, awesome. So the only thing remaining is that when I drop, first I need to clear these tiles, and then I need to drop in the right place. So for now, if I drop here, it's still valid. So we need to fix these two. Let's go to where we drop, which is the pieces. So let's see if we are doing the correct move or not. This should be something similar to what we are doing here. So let me grab this. And when I'm getting the rank and everything, I need to check that if app_state.candidate can find a m, where m at index 0 is the x, the drop that we are, the rank of the drop tile, so to say, and this is I. If this is valid, I mean, we have dropped the piece on one of the candidate moves, then I can do the move. Remove the piece from its original place, add it to the new position, and do the dispatch like so. So if this is a valid move, let's go back here, do a refresh. Yes, so if I'm doing an invalid move, it's not working. But if I do a valid move, then it's working. Cool. Now the only thing that I need to do is that whether it's a valid move or not, I need to clear those marks. So you can see if I drop, this should go away, whether I'm dropping in right place or in the wrong place. So when these are done, I need to dispatch another function, and let's call it clear candidates like so. I need to define this in the actions, so let's go here, have something like this, and clear candidates has no arguments, and it would just return clear candidate moves, no payload. And here, let me go to action types, add the type as well before I get an error. So this is like so, and in the reducer I can also add that one. So here this is clear candidate moves, and it returns the state as it was, and the candidate moves is just an empty array. So this one done, this one done, the move is correct, and here I can just do so that it does the import as well. Yeah, I'm getting the import. So if I move and drop, cool, move and drop, awesome, drop. Now I can move to all of this, so it's gonna work. Yep, this is basically over. These cannot move, and this can move because it's its turn. As you can see, all my pieces are rooks now. They can move like rooks. Cool. In the next part, we're going to move the knights, and then bishops, queens, kings, and then the pawns. So thank you for watching, and see you in the next video.